Okay, well, good morning to my eighth graders. I really miss you guys, and now that we're on the second full week of this, I'm really missing you all. So, just to let you know that I'm glad you guys are doing so great. Thank you for your hard work. It's been fun to work with you guys even through technology. So today is about permutations. That's probably a word you haven't heard before. A little bit of a weird one. Permutation, and what that basically means is the arrangement. Okay, so this is the arrangement of a group, arrangement of a whoops of a group of objects. Okay, so basically, a permutation is going to be something like this. If we have three teachers and four classes, and it'll be how many combinations could we come up with the three teachers and the four classes. It's gonna be something like that. So it's just the arrangement of the group of objects, okay? And there's usually two numbers, okay? You'll see that in our example. So the fun part about doing permutations, though, is that first we learn a principle called a factorial. And a factorial is easy because it's written with an exclamation point. Okay, if you're following on in your book, this is on page 425. Okay, and the way this works is if you see a number like 5 with a little factorial sign, what that means is you just do 5 times 4 times 3 times 2 times 1. Okay, that's just a rule. And if you do that on your calculator, I'm doing it right now, you get 120. So what that means is that 5 factorial, the factorial of 5 or 5 exclamation point is 120. Okay, if you need to pause the screen, write that down. That's an easy way to do it. Here's another way we can do it. We could do something like 6 factorial, and that'd be 6 times 5. You see how we start with the number here, and then we just decrease all the way down to 1. And in that case, we have that number 6 times 5 times 4 times 3 times 2, which is 720. So you can see when you have a big number here in the exclamation point, the bigger the number, the factorial. Okay, that's very easy to do. Here, if you need to pause that, go ahead. Here is another way that they'll write it. Sometimes they'll do 4 factorial inside of parentheses 3 factorial. Now, all we do in this one is we just do this one first. So that we do that one first. We do 4 times 3 times 2 times 1. And 4 times 3 times 2 times 1 is 24. Now, I just leave the 24 sit there. Right now, this has become the 24, so I can actually write that above there. That now is a 24. Then I take this 3 and do 3 times 2 times 1, factorial of it, and 3 times 2 times 1 is 6. So now I'm left with 6 over here. So now I have 24 times 6. And so down here I do 24 times 6 and 24 times 6. And that, when I punch in the calculator, equals a mighty total of 144. Okay, 144. So that's my final answer. So that's how you do it. If it has multiple, I'm going to do one more real fast just to show you, and then I'm going to get into the more complicated part of our lesson. Okay, so for example, one of these problems on this might be 3 comma 5 factorial. Now I always do the factorial first, so I do 5 times 4 times 3 times 2 times 1, and we already did that. That was 120. Okay, now I replace that 5 factorial with a 120, but this 3 doesn't have a factorial. So what I do to write the answer is I just do 3 times 120. Ooh, don't do that. 3 times 120. When I do that in the calculator, 3 times 120, I get a solid 360. So the answer to this overall problem is 360. Okay, so unlike the last one, this one did not have a factorial, so I just use parentheses around it and multiply times with the factorial of the other one. Okay, that one's not too bad. I'm sure you guys understand that. I believe in your abilities. That's the easy part. Now where it gets hard is we have this little formula. So we have P standing for permutations, but we're going to have n to the p and that to the r. So we're going to have little n, big P, little r. Now you say, what in the world does that mean? Well, in this one, n is the total number. Okay? N is the total number. P just stands for permutation. Okay, so it's not hard. And then R stands for the time. So it's the smaller value. Okay? So if they give us a problem, what it will look like something like this. If they said that there are 5 letters, okay, 5 letters, and they're taken 3 at a time. Okay, 5 letters taken 3 at a time. Now you can see which one is the total number. Well, that's the 5 letters. So when I go to write this formula, I write 5p, and then what is at the time? See, it's the smaller value, or this is also at a time. Okay, and so that's 5p3. Okay, now you see how we do that. The bigger one always goes for n, the smaller one goes for r, okay, for the, basically for the number that we will have. Now, that doesn't mean anything, right? To you, you're like, what in the world? What does 5p3 mean? Okay, so pause your screen if you haven't written that down. Here we go. I'm going to explain what 5p3 means. Okay, 5p3. So the way this works is that means that on the top is the 5 factorial, and on the bottom is 5 minus 3 factorial. Okay, so if you look in your book on the formula, this is what the formula actually is. N to the PR is equal to n factorial over n minus r factorial. Now, you don't have to necessarily understand how all this works. That's why I'm giving you this example right here. So just follow along with that. So the top stays the same, right? That's 5 times 5 times 3, or sorry, 5 times 4 times 3 times 2 times 1. Okay, that's what we learned at the beginning of our lesson. Now this down here, what is 5 minus 3? That is 2. And 2 like that is just 2 times 1. Okay, so we can erase this right here. 2 to that is the same thing as 2 times 1. Well, the top, when I multiply that out, this top turns into 120. And this, oops, sorry, we don't multiply it out, actually. So what we do before we even do that is we say what in the top is the same in the bottom, and we cancel those out. So this 1 cancels, and this 2 cancels. So now the answer is just that right there. 5 times 4 times 3, which is 60 when you type it in the calculator. So 5p3 is the same as 60. Okay, so I showed you how to do it that way, crossing out. So if you need to pause it, go ahead and do that. But what if it's a bigger number? Like, what if it's something like 8p4, right? I don't want to know 8 factorial divided by, right, this is 8 minus 4 factorial, which is 8 factorial over 4 factorial, right? 8 minus 4 is 4. Okay? Now that's kind of hard to look at because I'm like, I don't want to draw that out and, you know, do 8 times 7 times 6 times and then cross out, right? I don't want to do that. So the cool way to do this is whatever number is left, you just go to that number. Okay? So this answer, right, I'll show you how we'll do it. We'll write it out, and then we'll show you how to do it. So 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. All of that divided by 4 times 3 times 2 times 1. Okay, now I cancel out. I go 1, 1, 2, 2, 3, 3, 4, 4. Now look what I'm left with here. I'm left with those. So it goes all the way until the number 4, but I don't include the number 4. So it's 4 times. Okay, if you want to think of it that way, this is how many times you're going to do this. So see, this is 1, 2, 3, 4. And see how it matches this number 4? So that means I just type in the calculator 8 times 7 times 6 times 5. And 8 times 7 times 6 times 5 is 1,680. Okay, so I can do it this way by counting these out, but look, I don't have to do it this way, and I'll show you how we don't have to do that every time. So if you need to pause, pause. We're almost done with the video. So let's say that it's 7p3. Okay, I can just say, look at this. I don't even have to rewrite this. I can say there's going to be 3 times, right? 3 of them. So it's going to be 7 times 6 times 5. So my answer when I multiply that is 30 times 7, which is 210. Okay, look at, I'll show you another one. What if I do 9p2? It only means I'm going to have 2 starting at 9, so I'm going to have 9 times 8, which is 72. Okay, it's only the number that I'm going to use. So then what if I do something like 10p7? Right, I'm going to have 10 times 9 times 8 times 7. I got to do it 7 times, right? 1, 2, 3, 4 times 6 times 5. 1, 2, 3, 4, 5, 6, 7. And I multiply that in. It's going to be a huge old number, which I may not even write down on the screen, but I'll tell you what it is. It is 604,800. Right? That's a huge number, but it comes from this right here, okay? So I hope that makes sense. If you have questions, please watch this again, pause it. So here is the homework for this. It is on page 427, and this is 10.6. We're going to do numbers 1 through 37 odd, and if you guys do this, we will not have any homework over Easter weekend. So this is our last homework until next week. So I hope you enjoy this. For Wednesday morning. Thursday, we'll probably have an informational video, but probably not have homework. So, straight over and out.